dear students, we have been discussing this AP from last couple of days. So AP, you know what is in AP? AP is a list of numbers in which each term is obtained by adding the preceding term, a fixed number. That fixed number is called a common difference. So question number 11 is 3, 15, 7, 27, 39. This is an AP. We have to find which term of this AP is 132 more than its 54th term. Now we have to find that which term. Here A is equal to 3. What is D? D is 15 minus 3. This is 12. So A first term is 3 and D is 12. We have to find which term of this AP is 132 more than its 54th term. Suppose nth term. Let nth term is 132 more than 54th term. Nth term is an. So this is equivalent 54th term plus 132. A 54. 54th term plus 132. A, and you know this is A plus n minus 1 into D is equivalent. 54th term is A plus 53D, you know it. 54th term is A plus 53D plus 132. A and A will cancel. We are left with n minus 1 into D. What is D here? It is 12. Is equivalent to 53 into D is 53 into 12 plus 132. So n minus 1 into 12 is equivalent to 12 3s are 36, 12 5s are 60, 63, plus 132. This is n minus 1 into 12 is equivalent. This is 8, 3, 3, 6, 7, 768. So n minus 1 is equivalent 768 divided by 12. So this is 768 divided by 12. So it is n minus 1 is equivalent 12 ones are 12, 64s are, this is 64. So n minus 1 is equal to 64. So n is equal to 64 plus 1. What is n? It is 65. So 65th term is 132 more than it is 54th term. So this was question number 12. Sorry, 11. Let me repeat. This is 13. This is 15. 3, 15, 27, 39. This is an AP. And we have to find which term of this AP will be 132 more than it is 54th term. More means plus. So now let the nth term be 132 more than it is 54th term. So an is equal to nth term is an is equal to a 54 plus 132, and an you know a plus n minus 1 into d is equal to 54th term is a plus 53d plus 132. A and A cancels up. We are left with n minus 1 into D. What is D here? D is here 12 is equal to 53 into D. D is 12 is equal plus 132. So n minus 1 into 12 is 636 plus 132. N minus 1 into 12 is 768. N minus 1 is equal to 768 divided by 12. 12 ones are 64s are. So n minus 1 is equal to 64. What is n? N is 65. So that is it. This was question number 11. So let us proceed further. So far this AP is concerned. Now question number 12 is two APs have the same common difference. Now there are two APs in which the common difference is same. The difference between their 100th term is 100. Now it is given that their difference between their 100th term is 100. And we have to find what is the difference between their 1000th term. Let us take two APs. Let the two APs APs are A, comma A plus D, comma A plus 2D, so on, so on. This is an AP. Second is A, comma A capital A, this A plus D, but this D must be same. Common difference is same, it is given. So this capital A plus 2D, so on. These are the two APs. First is small a and A plus D, A plus 2D, so on. And you have to find the difference between their hundredth term. Let us take this first AP. This is first AP and this is second. First AP, let us take the hundredth term. This is A 100. This is equal to A plus 99D. Okay. Now let us from this AP, let us take 100. This is A, capital A 100. This is A plus 99D. Now it is given that their difference is equal to 100. Now the difference between this is A 100 minus capital A 100, this is equivalent to 100. This is given. Now what is A 100? This small a. This is A plus 99D minus, then capital A 100 is capital A plus 99D. So this is equivalent to 100. This is equivalent to 100. Now this is A plus 99D. This will become minus A. Minus 99D is equal to 100. So 99D and 99D will go. We are left with A minus A is equal to 100. Name this equation first. Suppose this is equation A. Now we have to find the difference between their thousandth term. Now what is the thousandth term of this AP? A 1000. This is equivalent to A plus 999D. And this capital A 1000. This is A plus 999D. Now we have to find the difference between the thousandth terms. That is A 1000 minus capital A 1000. This is to be found. This is A plus 999D minus this A capital A 1000 is A plus 999D. Now this is A plus 999D. This is minus A minus 999D. This and this will go. We are left with A minus A. And A minus A is equal to 100. So this is equal to 100 by equation A. Therefore, the difference between their thousandth term is also 100. So difference between their hundredth term, we find it that it is equal to 100. It was given that the difference between their hundredth term is 100. Now we found that the difference between their thousandth terms is also 100. So this was question number 12. And let me explain it further. We took two APs. Suppose this is small a, then comma A plus D, then comma A plus 2D. Then this another AP. This capital A and capital A plus D, capital A plus 2D. These are these are the general forms of an AP. So we took these two APs. Now what is the hundredth term of this AP? First AP. This A100, this is A plus 99D. And this is the hundredth. What is the hundredth term of this AP? This again A plus 99D. Now their difference, it is given that, is given in the question that their difference is equal to 100. So we write here A100 minus, difference means minus, A capital A100, this is given that is equal to 100. So A100 is A plus 99D, we write here A plus 99D minus A plus 99D, and we take the brackets off, that we are left with A plus 99D minus A minus 99D is equal to 100. So A minus A is equal to 100. Now let us take the this thousandth term of this AP. It is A plus 999D, we know it. And thousandth term of this AP, second AP, it is again A plus 999D. Let's find their difference. And their difference came equal to A minus A. And what is our A minus A? It is 100. So the difference between their 100 term is also 100. Now, very important question. How many 3-digit numbers are divisible by 7? We have to find the number of 3-digit numbers which are divisible by 7. Now we know that 3-digit numbers start from 100. 101, 102, 103, so on, so on, so on, so on, 999. These are 3-digit numbers. We know that 3-digit numbers start from what? 100. And we have to find from these 3-digit numbers, from 100 to 999, what is the number of 3-digit numbers which are divisible by 7. And we know the first number which is divisible by 3-digit number which is divisible by 7 is 105, 105, then it is 112, then 100, 119, so on, so on, so on. What is the last number below this 999 which is divisible by 7? That is 994. 7 ones are 7, 7 ones are 7, 4s are 7, 2. Yes, it is 994 which is divisible by 7. So 105 is the first 3-digit number that is divisible by 5, and then it is obviously what? It is 112, then 119. These are the numbers which are divisible by 7, and last number less than this 999. This is 994 which is divisible by 7. So what is our AP now here? Now the AP is 105, 112, 119, so on, so on, 994. So here, what is A here? It is 105. And what is D? It is 112 minus 105. This is 7. So let AN is AN. Our AN is here 994. AN is here 994. The last 3-digit number less than 999 which is divisible by 7. So A plus N minus 1 into D is equivalent to 994. What is our A? It is 105 plus N minus 1 into D. D is 7 is equal to 994. So N minus 1 into 7 is equal to 994 minus 105. So N minus 1 into 7 is equivalent. This is 9. This is 8. 889. 889. So N minus 1 is equivalent 889 divided by 7. 7 ones are 7. 7 ones are 7. 7 twos are 14. 7 sevens are 49. So N minus 1 is equal to 127. What is N? This is 127 plus 1. So N is equivalent to 128. So N is the number of digits, 3-digit numbers which are divisible by 7 are 128. 128. So this was very important question. You write the first 3-digit number which is divisible by 105. Then the second is 112. Then the third is 109. And the last is 994. So we form an AP like this. And AN is equal to 900. It's the last term. A 994. So A plus N minus 1 into D is equal to 994. And we found that N, the number of 3-digit numbers which are divisible by 7 is 128 by making use of this AP. Now again, this is question number 14. How many multiples of 4 lie between 10 and 250? Now let us see again. 10 and 250. Now we have to find how many multiples of 4. Multiples again means the which is the number which are divisible by 4. So the first number which is from 10 to 250. After 10, 11, and then it is 12. 12 is divisible by 4. Then it is 16. 4 4s are 16. Then it is 20. Yes, it is 24. 4 3s are 4 4s are 4 5s are 24 6s are 24. So on, so on, so on. And this is not divisible by this 4. It is 248. Yes, 248 is divisible by 4, or it is a multiple of 4. Here again, A is equal to 12. What is D? It is 16 minus 12. This is 4. And what is A n here? It is 248. A plus n minus 1 into D is equivalent to 248. So what is our A? It is 12 plus n minus 1 into D. What is D here? It is 4 is equal to 248. So n minus 1 into 4 is equal to 248 minus 12. So n minus 1 into 4 is equal to, this is 6, 3, 136. Sorry, it is 236. So n minus 1 is equivalent of 236 divided by 4. 4 5s are 20. 4 9s are 36. So n minus 1 is equal to 59. What is n? N is 59 plus 1. So n is equal to 60. So 60 numbers which lie between 200 and 10 to 250 are the multiples of 4. This was question number 14, a simple one. Now question number 15. Question number 15 is like this. For what values of n, the nth term of APs, these are two APs are given, are equal. We have to find that which term, for what value of n, the two APs are equal. Two APs are given. So let's attempt this question also. First AP is this 63, 65 and 67. This is one AP. Second AP is 3, 10, 17. Okay. Here A is equal to 63. What is D here? 65 minus this is minus 2. Sorry, this is 2. 65 minus 63 is 2. So this is an AP. And what for here A is equal to 3, and what is D here? This is 7. 10 minus 3 is 7. Now we have to find which value, for which value of n the two APs are equal. Let an, what is the an nth term of this AP? This is A plus n minus 1 into D. And for this, an is equal to A plus n minus 1 into D. So this is A, what is A here? It is 63 plus n minus 1 into D. D is 2. This should be equal to. This should be equal to. Yes, what is A here? It is 3 plus n minus 1 into D. D is here 7. D is here 7. So this is 63 plus 2n minus 2. 2 into n is 2n. 2 minus, this is minus 2 is equal to 3 plus 7 into n is 7n minus 7. Now taking these n on one side, this is 61 plus 2n, yes, is equal to 7n minus 4. Now taking these two on one side, this is 2n minus 7n is equal to minus 4 minus 61. So this is minus 5n is equal to minus 65. Yes, minus and minus will go. 5n is equal to 65. What is n? N is 65 divided by 5, 13 is r. So n is equal to 13. So when n is 13, these two APs are equal. These are two APs, 63, 65, 67 and 3, 10, 17. These are two APs. Now we have to find the value of n for which the two APs are equal. Now here A is equal to 63 first term, and D you know is second term minus first term, that is 2. So nth term is A plus n minus 1 into D for this AP, and for this AP again A is equal to 3 and D is equal to 7. A nth term is A plus n minus 1 into D. Now we have to find the value of for n in which for which the two APs are equal. This AP is equal to this AP. So this AP is 63 plus n minus 1 into 2 is equal to 3 plus n minus 1 into 7. Now we find the value of n. 63, 2 into n is 2n, 2 ones are minus 2, 3 is 3, 7 into n is 7n, 7 ones are minus 7. Now this is 63 minus 2 is 61 plus 2n, 7n, 3 minus 7 is minus 4. So taking these n's on this side, so this is 2n, 7n shifted it to this side, this is minus 7n is equal to minus 4, and 61 we shifted to this side, is minus 61. So this is 7 is minus, so 7n minus 2n, this 5n is equal to minus 4 minus 6 is minus 65. So minus minus 5n is equal to minus 65, minus and minus will go, 5n is equal to 65. What is n? It is 65 divided by 5, 13 is r, so n is equal to 13. So up to question number 15 we attempted. Now there are some more questions, 16, 17, 18, 19 and 20. Tomorrow inshallah. Till then, Allah Hafiz.